Hello guys, this is Prime Concept. You're welcome to my channel once again. We are still considering the concept of set theory. In this video, I want to look at Venn diagram. So what is actually Venn diagram? Venn diagram was introduced by a mathematician, John Venn. And is an important diagram that helps to simplify what's the name? Word problems in mathematics under set. So what is Venn diagram? Venn diagram is a diagram that shows the interrelationship between different sets. It's a diagram that shows the interrelationship. It is a diagram that shows the interrelationship between sets or between different sets. That diagram is known as the Venn diagram. Now, the Venn diagram is usually drawn with a rectangle. So, a rectangle represents the total Venn diagram, then with circles inside that rectangle indicating the different sets and how they are connected. So, that is the Venn diagram. It's usually denoted this way with a rectangle, where this rectangle indicates the universal set. So somewhere around here, we usually open it and then write this, telling you that the whole of this rectangle represents the what? Universal set. So anytime I'm dealing with the universal set, anything you can find within this rectangle is a member of the universal set. Then secondly, if you have individual sets, so let's say set A, set B, they are usually inscribed inside this rectangle and they are denoted. Every different set is denoted with a circle. If two sets are related or they have common elements, then there will be a circle that connects each other. Now, for example, let's start very simple. Let's look at the Venn diagram for only one set and then the universal set. I'll say we have the universal set, this, and it contains the element 1, 2, 3, 4, and then 5. Then we have another set A that has the elements 2, 3, and 4. So you have this. Now, if you want to draw the Venn diagram for this, it's going to be this. This is the universal set. The universal set would contain elements. I want to write all the elements for the universal set. 1, 2, 3. We don't use a comma for this. We just drop them that way. 3, 4, and what? 5. So I want to draw this. Now you would see that my universal set contains 1, 2, 3, 4, 5. And if you look here, you have 1, 2, 3, 4, 5. So this is the universal set, everything here. But then we have a set A that contains the elements 2, 3, and 4. So to identify the set A, we use circles. So it means that if I put a circle around 2, 3, and 4, then this is the Venn diagram for these two sets, right? Where you would notice that this is for A, where you notice that everything in this circle are members of A, but then some values, some elements are not inside this circle, but they are inside the rectangle, which is what? 1 and 5. So meaning that a totality of this circle plus what is outside the circle gives rise to what? The universal set. So this is what we know as Venn diagram. So the circle represents a particular set, while the circle plus everything outside the circle represents what? The universal set. Now let's say we have another set B. So we have two sets. Now we have a set B that contains elements, and let's say 2 and 5. 2 and 5. Let's go this way. So we have another element that's another set that contains elements 2 and 5. Now we want to look at a Venn diagram now for two sets. So let me do a fresh diagram. This is my rectangle. So I'm going to draw two circles. Now, before you draw circles, when you have two sets, the first thing you want to check is, do those two sets have an intersection? Intersection means common elements. Do they have a common element? Let's find out. Okay, you can clearly see that there is 2 here and there is also 2 here, so they have something in common. So hence that they have something in common, you're going to draw 2 circles that overlap each other, telling you once there is a common element there must be an overlap in your circles. So I would have this circle, I'll call this circle A. Then there must be an overlap with another circle which I will call circle what? B. So this first circle would contain the elements of A. The second circle would contain the element of B. Now before you fill up these circles, it is best for you to start filling up from their interrelationship, what they have in common. You start there. So their overlap. This overlap represents what they have in common. So what do they have in common? They have the element 2 in common. So I'll put 2 here. You don't have to repeat 2. In set, repetition is not needed. Even if you repeat, we consider it to be one element. So I'll put what they have in common, which is 2. Then let's go for A. Since we already have 2, which we have written, what is left in A? It is 3 and what? 3 and 4. What do we have for B? B, what you have left for B is what? Is 5. So you would see that we've written the elements for A, which is 3, 4, and what? 2 are present in A, because this is a continuous circle. If you want to check the elements that are in B, you would have 2 and 5, right? But if you want to check the elements that are only present in B, it is going to be what? 5. The elements that are only present in A is going to be what? 3 and 4. When you say only present in A, it means that it is in A but is not found any other place. It is 3 and 4. But elements that are in A but not strictly in A, then you say 3, 4, and 2. So I believe it is clear, but we're not done because we can still have some elements. Now let's check. So we've written 2, 3, 4, 5. 2, 3, 4, 5. Something is left. 1, which is not a member of A and B. So where do we drop it? You drop it inside the rectangle. Then with this, you are done with the Venn diagram for this. So this is a Venn diagram for 2 sets. So quickly we want to look at Venn diagram for 3 sets. So and just this is how it is, after which in our subsequent video we're now going to look at word problems for Venn diagram and see how we can solve them. This is just a basic introduction to Venn diagram. And say we have 3 sets. Let me still make do with this. Say we have 3 sets. This is set B. Let me increase this. 6, 7. And this is A. Then this set C. It has elements 4, 6, and let's say 2. So it has this element. Now I want to draw this Venn diagram. It's going to start with our rectangle with the universal set. This. Now, first thing you want to also ask yourself before you draw your circles is, do these 3 sets have an interconnection? Let's see if they have interrelationship. Now, you can find 2 in A, you can find 2 in B, you can also find 2 in C. So it means the 3 of them would have a point of intersection. 3 of them would have a common point of intersection. So this is going to be something like this. Something like this. So something like this. So the 3 of them have a common point of intersection. We're still going to adjust our diagram, or better still, let me still make it easy for us. B and C. Okay, we're going to just adjust our diagram. So if I call this A, I call this B, and I call this C. The point of intersection for the 3 of them is this. So it means that the 3 of them are interconnected at this point, which the value that connects the three of them is 2. So I'm going to place 2 here. So that's the first thing you should always do. Then the second thing is want to find out if there's a connection between A and B. So let's see if A and B have a connection. A and B have a connection just for A and B. They don't have anything in common. A and B don't have anything in common. So it means this part, I will erase this part, is not necessary. So this is what I have strictly. Is it possible to draw this? Okay. Okay, let's move on. There's nothing here. They don't have anything in common. Now, very quickly, let's see if B and C have something in common. B and C, they don't have anything in common. Let's see, A and C, A and C have 4 in common. A and C has 4 in common. This does not have anything in common. So I can do it this way. Let's see. Then okay, let's do the diagram this way. Then for A, we have 2, which is already here. We have 3, and then we have 4, which is already here. For B, we have 2, which is here, and then we have 5. For C, we have 4, we have 2, and then we have 6. So these are the members of this. Then we are not done, because in our universal set we still have some elements that are present in the universal set, such as 1, what else? 7. 1 and 7. So we have 1 and we have 7. So if you put all this together, we have 1, 2, 3, 4, 5, 6, 7. So then this is our diagram for the 3 sets, right? I believe that this is very clear to you. Now I'm going to give you one more explanation. Then we are done with this introductory part of the video. Now, we want to look at different relationships for Venn diagram, just for 2 sets. Now, say we want to look at intersection of sets. Now, if I have 2 sets like this, I have this is a set A, and then I have this is a set B. If I want to indicate, say I'm not dealing with elements, for example, I want to indicate the intersection between A and B, which is denoted symbolically as this. If I want to indicate the intersection, I'm going to look at what they have in common, which is this region. So I will shade it. So when I shade, the shaded region is the region that talks about the set relationship. So this simply represents A intersection what? B. So quickly I want to look at union of sets, which is denoted as this. So it's going to be a diagram this way. I have this, say this is A and this is B. The union is going to be shading everything, because union means combining all the elements of A and what? B. So the union is going to be obtained by shading everything. Now, say you want to deal with number 3, complement. I'm dealing with a relative complement in this case. So I'm going to have, say I have A, and then I have B, this A, and this is B. So if I want to find the complement of A with respect to B, which is given as this, so it means you're removing B from A. What is left in A? So this is it, this part. this is what will be left in A. So this shaded part simply represents A difference what? B. So these are some basic relationships I would want you to understand about Venn diagram. So I will be stopping this video at this point because it's just an introductory part for Venn diagram. In my next video, we'll be looking at problems, world problems on Venn diagram, and see how we can tackle these problems, relate them to Venn diagram, and be able to solve them mathematically. So if you have watched this video up to this point, please do well to hit the like button, hit the subscribe button, drop a comment, then share the video with your friends. Tell them it is prime concept. I'll see you in my next video. Thank you.